Hi, we're going to use this drum kit to explore fractions through something we're all familiar with, music and rhythm. I'm going to define the elements of rhythm and show you how the math we learn in traditional math class is used within the structural elements of music. Now let's look at musical notes and their lengths so we can understand the values we'll use to build our beats and make music. Whole notes, half notes, quarter notes, eighth notes, 16th notes, and 32nd notes make up the basis of the common time signature 4/4. We can use the equivalent fractional values of these notes to help us understand rhythm mathematically. You'll notice that the naming convention for each note corresponds to a mathematical value. If we understand how the words translate into math, we can build our calculations. For example, if we're finding half of a quarter note, we interpret that as 1/2 times 1/4. When multiplying fractions, we multiply the numerators to get a new numerator, and we multiply the denominators to get a new denominator. The product is 1/8, or in musical notation, an eighth note. We can utilize this method to subdivide all the values to get the next note. Half of a whole note is a half of a half is a quarter, half of a quarter is an eighth, half of an eighth is a 16th, and half of a 16th is a 32nd. The same method is used to define triplets, which strummers like to use to spice up their fills. So a third of a whole is a third, half of a third is a sixth, half of a sixth is a 12th, and half of a 12th is a 24th. Now that we've examined the different values, let's listen to the subdivisions as we look at the math behind them. In music, the values in a complete measure add to 1. We'll show this as we listen and compare the different notes we've mathematically subdivided. That will be our basic quarter note tempo. I'll use the snare drum to define each of the note values, starting with a whole note. You'll notice that the snare hits at the beginning of each of those 4 counts, defining the whole measure. The half note will be half of that duration. Moving on to a quarter note, you'll notice they hit all at the same time. As we move on, you'll notice that the snare drum will just double as we keep the bass drum on the quarter note. So eighth notes, and 16th notes. These are the basic subdivisions of rhythm. Musicians tend to pick one of these to count or feel the tempo of the song. The most popular subdivisions are the quarter note or the eighth note. Given this beat as an example, we see how each note has a fractional value. A properly constructed measure will have rhythmic fractions that add up to 1. For the values to have different denominators, we have to use common denominators to express the fractions properly so we can add them together. Each of these numbers is a factor of 16, so we can use 16 as the common denominator. To get the denominators to be 16, without changing the value of the fraction, we multiply each by a fractional equivalent to 1. We can confirm the math audibly because 2 16th notes fit into the space of 1 eighth note. Once the denominators are all the same, we add the numerators and find that the total is 16 over 16, or 1, which is the complete measure. The next step musically is completing the whole to inspire creative space within a beat. Or more simply put, we need to improv the beat. Remember, when adding the rhythm values in a measure, we need to add up to 1 to make a complete feeling beat. Because we know that a measure needs to add up to a value of 1, we can take one of the beats we had already played, remove part of the end of the measure, and use a math equation to represent the missing part of the measure. By replacing the missing section with a value of x, we can use algebra to find out what fraction of the measure has been removed. Given the notes at the beginning of the measure, we have a series of like terms being added to an x term. By summing these like values, we make solving for x a little easier. If a constant plus x is equal to 1, then 1 minus that constant is x. Solving for x defines the particular space that we want to improv, and when we know x, we can make a drum fill out of any part of the measure. By grabbing different amounts of the measure and understanding the space it occupies, we can create audibly comfortable drum fills within drum beats. Examining the musical working space through math helps to define what we feel when we listen to music. Feeling the groove in our bodies or hearing it in our heads is a physical way of defining the space we just represented mathematically. This written system lets us examine the relationship between rhythm and math, from what we hear to what we can write out. This gives us tools to teach, write, learn, and play music that we've never heard before. There is no one way to make and write music, and a better understanding of the elements that define what you're hearing can enhance your creativity as you write. Now let's use our newfound understanding of fractional space to improvise drum fills and have some fun making music.